Hello everybody, it's Brainy Diode, and I am trying something new for my channel. This will be my first attempt to put voiceover with music in one of my videos, so hopefully that goes well and not absolutely terribly. Now, before I begin, I should warn you that the following video contains discussion of the extinction of humanity, the end of the universe, and other such items that may be disturbing to some viewers. If you are uncomfortable with these and similar topics, I would recommend you refrain from watching this video. Also, this video contains spoilers for seasons 3, 8, and 9 of the modern series of Doctor Who. If you have not seen these and wish to remain spoiler-free, please consider revisiting this video once you have. Also, before I begin, please note that this video is based solely on the modern series and the conclusion I draw is therefore not affected by the classic series or any non-television Doctor Who releases. With that being said, and without further ado, the end of the universe according to Doctor Who. The Doctor has claimed to be at the end of the universe no less than 3 times now in the modern series alone, but each visit appears a bit different. What kind of ending does Doctor Who predict for the universe, and does it correspond with scientific theory on the matter? Let's take a look. First of all, we should establish a timeline. Which end of the universe, air quotes, comes in which order? When the Doctor first appeared in the end, it was in the episode Utopia, the first part of the Season 3 finale. This was stated to be the year 100 trillion, but neither of the other visits have a set time frame, which makes things a bit harder to nail down. Not only this, but blatant contradictions come into play as well. In Utopia, the Doctor claims that every star in the universe is dead, but it is later revealed in the episode that there are at least 2 planets left. However, in Listen from Season 8, the Doctor claims to have landed on the last planet in the universe, but said planet is clearly shown orbiting a still-burning star. One thing we can establish right away, though, is that the Doctor's visit to the end of the universe in Hellbent, the Season 9 finale, is the final one of these 3. We easily determine this because the Doctor claims that Hell is about 5 minutes away during this scene, while both other visits to the end of the universe clearly take place over the course of several hours. As for the other 2, I'm going to place Utopia before the Utopia visit before the Listen visit for one very important reason. There was life in Utopia, there wasn't in Listen. How then do you explain the star the Listen planet orbits if every star in the universe was dead? The answer is very simple. The stars weren't all dead. In the book The 5 Ages of the Universe, astronomers Fred Adams and Greg Lawlin, I apologize for my mispronunciation, lay out 5 eras in the universe's development. We are currently in the Stelliferous era, in which stars produce most of the universe's energy. The year 100 trillion, when Utopia is said to take place, can be expressed in scientific notation as 1 times 10 to the 14th, or a 1 followed by 14 zeros, past the beginning of the universe. The Stelliferous era is predicted to end in approximately the year 1 times 10 to the 13th, 90 trillion years before Utopia, after which the universe will enter the Degenerate era. In the Degenerate era, stars will be long past their prime, but neutron stars, white dwarfs, and brown dwarfs will still exist. Over the course of the Degenerate era, I am having trouble pronouncing that today for some reason, these star corpses, as well as any planets, asteroids, comets, and other objects will gradually dissolve due to proton decay. Because Utopia takes place very early in the Degenerate era and proton decay is an incredibly long process, we can assume that it hasn't done too much of a number on the Utopia planet or whatever kind of star corpse it orbits. Proton decay will also cause white dwarfs to put out some heat energy. It will be less than the heat energy provided by a typical microwave oven, but it is likely to be sufficient for whatever forms of life may exist then, thus the possibility for both Utopia and Listen. After the last star in the universe completes its dissolution, approximately 1 times 10 to the 40 years in the future, the universe will enter the black hole era when, as the name suggests, the only energy-producing matter remaining in the universe will be contained in black holes. Eventually,
The black hole era will come to an end, however, because due to a special type of radiation black holes create known as Hawking radiation, named after physicist Stephen Hawking, who performed the calculations both predicting and proving its existence, black holes lose mass over an incredibly long period of time. Eventually, sometime around the year 1 times 10 to the 92, even black holes will have disappeared entirely from the universe. At this point, the universe will be in its final stage, the Dark Era. During the Dark Era, all matter and energy in the universe will be distributed perfectly uniformly, meaning that no structures can be created and no heat or light can be radiated. The Dark Era will never, ever end, and the universe will continue to exist in a state of perfect equilibrium until the end of time, if such a thing as the end of time even exists. This is a condition known as heat death, and it's rather saddening to think about. But fortunately, or perhaps unfortunately for us, the universe's death depicted in Hellbent seems far too bright and violent to be heat death, so it's likely something else. There are 3 major theories for how the universe will end. The first is the heat death scenario, which I just described, and the other 2 are known as the Big Crunch and the Big Rip. I'm sure most people watching this video are familiar with the Big Bang Theory, the actual scientific theory, not the TV show, but in case you aren't, I'll briefly describe it. According to the Big Bang Theory, which is the most widely accepted theory pertaining to the universe's origin, all matter and energy in the universe was once, a little less than 13.5 billion years ago, condensed in an infinitely small point known as the singularity. Suddenly, some sort of fluctuation in the singularity caused the entire thing to explode outward. The singularity continued to expand, and over time, matter formed and condensed into stars and planets that eventually formed the universe as it is today. According to the calculations of several astronomers and physicists of very high repute, the universe is still expanding from the force exerted by the Big Bang. However, if you throw a rock into the air, it will eventually slow, stop, and come back down due to Earth's gravitational pull. Due to the fact that all matter in the universe has a gravitational force, scientists once thought that, like a stone thrown into the air, the universe's expansion would slow, eventually cease, and then reverse. The gravitational pull of all the universe's matter on the universe's other matter would pull the universe back together into a new singularity. This scenario, seeming to be the exact opposite of the Big Bang, was called the Big Crunch. However, the dying universe portrayed in Hellbent certainly appears much smaller than today's universe, and there is an awful lot of empty space for the area to contain all of the mass in the universe. The Big Crunch doesn't seem like Doctor Who's projected end to the universe either. This leaves the Big Rip, which is not only seemingly the most likely way for the universe to go out, it is also perhaps the most terrifyingly violent. As I stated earlier, the universe continues to expand, but unlike you would think, our universe's expansion is speeding up, not slowing down. Edwin Hubble, one of the most famous astronomers in recent history, laid this out in Hubble's Law. Hubble's Law states that from any point in the universe, every galaxy appears to be moving away from the galaxy the point is located in, and the further away a galaxy is, the faster it moves away. Imagine a bunch of dots on a rubber band. Now imagine that rubber band is being stretched. Each dot is moving away from all the others, but none of the dots are at the center. Similarly to our rubber band metaphor, galaxies are not actually moving through space. Space is literally stretching out. Because of this, galaxies a certain distance away from our galaxy appear to be moving away from us at the speed of light, and further galaxies appear to be moving faster than light. This is possible because while physical matter cannot travel faster than light, space-time can and does. This still creates some obstacles, however. Light emitted at the present by such galaxies will never reach the Earth, because the light will lose all of its energy by the time it would reach the Earth. The boundary beyond which no galaxies can be seen is known as the Hubble horizon. Everything outside of the Hubble horizon might as well not exist, because it is physically impossible for us to ever reach it, or even see it, no matter how advanced our technology becomes. After all, if you're chasing something that moves faster than light, how do you ever catch up? Furthermore, because of the increasing speed of the universe's expansion, the Hubble horizon is shrinking, and it is shrinking faster every day. By about 60 million years prior to the Big Rip, the Hubble horizon will be smaller than the Milky Way galaxy. About 3 months before the Big Rip, the Hubble horizon will be smaller than the solar system. A few minutes prior to the end of the universe, gravity will be so weak compared to the expansion of the universe that even planets will be ripped apart. The floating scrap of Gallifrey me is waiting on in Hellbent, as well as the Doctor's prediction that the universe will end in about 5 minutes, seem to line up perfectly with this scenario, likely meaning that Doctor Who predicts that the universe will end in the Big Rip. But this isn't the end. In all of these time predictions, I have been giving a unit of time relative to how long it will be before the universe ends. So what is the end of the line? The rather terrifying answer is that the Big Rip occurs when the Hubble horizon shrinks to the point at which it is smaller than the smallest subatomic particle. At this point, even the tiniest bits of matter will have been ripped apart from each other forever, never to reunite. And the smallest units of matter possible will be floating alone in a vacuum forever. Downright disturbing, isn't it? When will this happen, though? The simple answer is that we have no idea. The equation devised to determine when the Big Rip will occur relies on a variable that represents the ratio of dark energy pressure to dark energy density, which we have no way to calculate with our current technology, especially since we aren't even sure exactly what dark energy is yet. The folks at Dartmouth College who created an equation determined that if the dark energy related variable equals negative 1.5, the Big Rip will occur about 22 billion years from now. But this isn't a prediction as much as it is a possible example. For now, we'll just have to wait and see, because only time will tell. I hope you enjoyed this analysis of what Doctor Who has to say about the end of the universe. If you liked the video, please visit my channel in the future for more facts, theories, and ideas. This is Brainy Diode, signing out.